Hey guys, we're going to talk about chemical formulas, writing formulas, the different types of formulas. So when you are looking at a chemical formula, you have two different types. You have your molecular covalent or covalent kind. That's where we're sharing the electrons. And then you have your ionic formula, which is the transfer of electrons. You also have acids, which is what we're going to talk about in this podcast. But what you can tell from a formula is that in a formula, however many you have, like there's one nitrogen here, and then there's 3 hydrogens. So the formula tells us how many of each element exists within that compound. So in this compound, we have 1 lead. There's 2 nitrate ions, which includes, we distribute that 2 to how many do you have? We have 2 nitrogens and 6 oxygens. And that's going to be very important in understanding when we get into the next unit where we're going to be balancing the chemical equations. But notice on this formula, if you don't put the parentheses that are listed over here, then this says that you've got 32 oxygens, not 2 nitrates. So you want to be very careful when you have polyatomic ions to make sure that you put parentheses around the polyatomic ion when you have more than 1. Okay, as I said, we're going to talk about acids today. A binary acid is 2 elements. And the way we name binary acids is we do hydro. Hydro means no oxygen. And then ic acid. So the first one is one that you're used to seeing before, hydrochloric acid. Well, we have HF here, so that's hydrofluoric acid. Then we have hydrobromic acid. And hydroiodic acid. We have hydrosulfuric acid. And the last one is hydronitric acid. So again, the hydro tells us that there's no oxygen. And we change our ending, our root. So what goes in here is your root of whatever element it's balancing with. But you'll notice, like with sulfuric, we didn't change the root, we added to the end. But nitrogen became nitric acid. Okay, an oxyacid is a hydrogen plus a polyatomic ion. And that's on the back of your pink sheets that y'all have. When you are trying to name it, you're going to look at the polyatomic ion that you're looking at, and if the polyatomic name ends in 8, then we change the ending to ic acid, and if it ends in ite, it becomes OUS acid, and we're going to do some examples. But when you look at your polyatomic ions, you'll find out the 8 has an extra oxygen. When you start looking at all those formulas, and we'll talk about that again in the ionic compound naming thing. But because it has more oxygen, so my thing is that it ate the extra oxygen, it now feels ic. And that helps you remember which ending are we changing it to. So let's do some practice naming. Okay, so when we look at this formula, H3PO4, we have to go to our polyatomic ion list, and we find out that PO4 3 negative is phosphate. So then we change our ending, and it is phosphoric acid. Okay, NO3 is nitrate. So that becomes nitric acid. ClO3 is chlorate. So that becomes chloric acid. And then CO3 is carbonate. And that is carbonic acid. So on the next part where we change our ice becomes us. So we look and we say PO3 is phosphite. So you can see that there's one less oxygen. And that is phosphorus. Acid. And NO2 is nitrite. So that becomes nitrous acid. And on the side note, the more oxygens that you have, the stronger the acid is. So if you're ever asked that question in the future, you'll know to look and say, oh, if it has more oxygens, it's stronger because it's because of the bonding involved, your Lewis structures and everything. So let's try to do some going backwards, writing the formulas from the names. This is what you're going to have to do a lot of the time. This is all year long. You're going to have to master this content because we're going to be doing it all year long. Hydrogen is always the first element in an acid, and you have to balance out whatever its charge, whatever the charge of the other thing is, because remember, hydrogen is just a 1+. So we know we're going to have a hydrogen here. So then we have to look at bromic acid. Well, bromic, the ick means it is bromate. And so I turn to my handy-dandy common polyatomic ion list because I never memorize any of these. I always have them available to me. Bromic is, so bromate, so that's Br O3 with a 1 negative. And because they're both a 1, one's a 1+, one's a 1 negative, they balance each other out. And we'll talk about balancing the charges out even more in my ionic lecture. So the formula is BrO3. Selenous means I had selenate. Of course, we do have our hydrogen. Selenite is SeO3 2 negative. So because I have a 2 negative on my selenite and a 1+, then that's why it requires 2 hydrogens to have an overall neutral charge. And hydrophosphoric acid. Hydro says, oh, I got no oxygen, so I'm looking at the element. Phosphoric means it's phosphorus. Hydrogen is a plus charge. We've already established. Phosphorus is P. Based on its location on the periodic table, always looking, never guessing. It's a 3 negative. So my formula for hydrophosphoric acid is H3P. I hope this helps, and ask questions in class.